Hello everyone, and today we are going to be talking about array lists in Java. And the other day we talked about arrays, and today we're going to be talking about a different type of data structure called array lists. And it's in java.util, so you have to import that if you want to use it. But array lists are basically very similar to arrays, except you can actually resize them and also like insert elements and remove elements, and it's just really more higher quality of life in general, easier to use in general. They're a bit like C++ vectors and Python lists. So let's look at how that works. So the syntax for creating an array list is very similar to in C++. So we have array list, and then the type that we want to, the type of each member in the array list, because we still can't have multiple types in it. So we want to have integer, and for some reason using simply int does not work. It just says like not recognized type or whatever. So and then equals new array list, and here you want to specify the type again, and this is a bit inconsistent syntax. It looks almost like Rust, but yeah, the syntax is a bit weird, that you have to restate the type. But essentially what this creates will be like an empty array list since of length 0, because we haven't specified a size, and we can actually like resize it later, so it doesn't really make sense to, it's not really necessary to specify a size at the beginning. And to add add elements to the array list, we can just use ArrayList dot add and a number. And this function is actually, this add method is actually overloaded. So one of the implementations, I believe, is a bool implementation. So a bool add, and then there's an index argument. Oh wait, there's only one element argument, I think. And then another one is a void. This is a bit inconsistent, but I'm not sure. So you give an index for this second overloading. You can specify an index, and it will actually insert it at the index, which is a bit like insert in Python. And this is just append. If you don't specify an index, it automatically appends it to the end of the array list. So let's check out how that works. First, let's add some more stuff to our array list, and we can try. So for int, or actually let's write something, because we're gonna be printing out the array list a lot. So let's just create something to print out the array list. Yeah, I think you have to specify the full type. Let's try. Okay, let's try this. So print list. All right, let's try. Compile, okay. Okay, so 1, 2, and 5, as we can see, it just keeps the elements that we inserted in the order that we inserted them. So you can imagine that the array looks something like this. And okay, so there's also the remove method, which you provide an index and it just removes for you. Oh, and by the way, this thing returns a boolean, and it returns true when it was successfully added, and I guess false when it was not successfully added. I'm not sure why it would ever not successfully add. Maybe like if you try to add like a different type of element, then maybe that wouldn't work. And yeah, so ArrayList can also store objects, all sorts of types, a bit more flexible than normal arrays. So yeah, as I was saying, you can use ArrayList dot remove, and then you provide an index to remove some element from the array list. And let's just hold on. Let's see. Print. Let's just print this in a more elegant way. Yeah, let's try this. And let's print it out again. Okay, yeah, so as we can see, in the second time it removed in the element at index 1. And if we remember from the previous video about arrays, in most programming languages, everything that's iterable is 0 index, which means that the first element of something that's iterable has always 0 as its index, and index 1 actually refers to the second argument as to the second element, and index 2 refers to the third element, and so on. It's a bit confusing, but yeah. Okay, so there's the remove method, which basically, as we can see, removes it from the index. So at index 1 there was a 2 here, and now it's gone, so yeah. And then there's one final thing we can use, which is ArrayList.set. Or actually, let's demonstrate how adding to an index works. So if we provide an index 1, and then we insert like an 100. So as we can see shortly, it can basically insert it to where it was. Hold on, gotta print it out again. So as we can see, it inserted an 100 to where like the 2 was just before at index 1. So yeah, it just basically replaces the element at that index and then pushes everything else back. I guess you could visualize it that way. But yeah, one last thing is ArrayList.set. So if you ever want to just change like an element in your array list, you don't have to remove something and then add it back. You can just do this. So if we want to restore this array list back to this form, then we can use .set, which takes an index as its first argument and a number as its second argument. So index 1 and element 5. So let's try that. Oops, forgot to print it out again. Okay, yeah, so as we can see, it inserted a 5 at index 1. And if we like change it to a 2, it'll just show a 2 here and so on. But yeah. And then if you want to access an element at a certain index, you can't use this form of indexing, because for some reason it seems to work exclusively for arrays, which is, I think, one inconsistency of Java that I don't really like. But so you can use .get. Actually, like, Java is very consistent with these set and get methods, so I guess that's one upside, is that, like, you know that every class you use will have some form of these methods, so you don't have to like memorize anything else, just set something and get something. But anyways, if you want to say get index 2, I'm expecting that it'll just, actually we need to print this out first. So if we want to print out the element at index 2, this is how it will work. Oops. Okay, yeah, so it printed out a 5 here, as we can see, and we don't need to print it out yet. So yeah, just use .get to get a specific element in the list. And then you can also traverse through array lists, similar how you would do arrays. There is one method that we just showed here, which is accessing each individual element. And remember, it isn't a mutable reference, so you can't directly modify the elements in the array by modifying this I variable. You can, however, use indexing. So if we want to do for I equals 0, and in here it's array.size, I believe. Size. So system ArrayList.get I. Okay, yeah, so it does work exactly as it does here. I do prefer using this method because it's cleaner in my opinion, because you have to type out all of this junk in this method, but I guess this is a bit more flexible in the sense that you can also mutate with this. So if we want to see how that looks, we could do like ArrayList.set I and set each element to 100. And this, remember, this basically means the index, and as we iterate, the index will change, so it'll eventually go through each element in the array. So let's just see if that works as expected. Ooh, okay. Okay, so yeah, it does indeed work as expected. And so one final little algorithm, I guess, that, well, not even an algorithm, that I'll leave as something to think about is linear search. And the reason I say linear is because there's linear search and there's something called binary search. So binary search is basically a more efficient way of searching. So first let's talk about what linear search is. So let's create a longer array list first. So say like 6, 8, 10. Print array list. Okay. And if we want to write like a search method, then we could do something like this: linear and then an integer of the thing we want to search for. Needle, like needle in the haystack. So we could do something like this. So or actually we could start with like int I equals -1. No. Okay, so no, okay. So int I equals 0. I size. I was just thinking maybe like we could implement something to catch like the error if the element is not there in the array. But so let's just keep it simple. Alright, so if basically we want to check if each individual element in the array is equal to the needle that we're looking for. So that is basically a linear search. So we're searching like in like a linear manner where, so just pretend like my cursor is like a pointer. So we're basically searching through this element and then this element, and then at each step we have to check if that element is equal to the thing we're looking for. And that's basically a linear search. And that, if you know anything about competitive programming and time complexity, so this runs in O(n) time. And this is because in the worst case scenario, the thing you're looking for is at the end of the list, which means that you have to go through every element in order to find that element. But yeah, so let's just see what that looks like first. So if array I is equal to needle, or actually we need to use .get, and then we can do break first, and then also index equals I. See if that works. And then if index is equal to -1, and then return -1. So this basically means that nothing was found. So we could do return index. And then let's just see if that works. I'm actually not sure. So remember this about linear search, and then later we'll briefly talk about binary search. So if we want to, so first let's print this new array out. Oops. Or actually we can just use linear search, and the first element is the first argument is the array, and then the second one is the thing we're searching for. So let's search for a 6. Oops, forgot the semicolon again. Okay, so as we can see, it returned 3, and it means basically that the 6 is at index 3, which is exactly what we expected. And linear search, it's maybe a bit inefficient if you have like a huge array list that you know is sorted. So if you know that an array list is sorted, you can sort of take advantage of that, because there's a strategy called binary search where you can start in the middle, and then you can check if that element in the middle is greater or less than the number that you just encountered. So if, for example, like if you're playing that game where somebody asks you to like guess a number from 1 to 10, and then they'll tell you if it's more or less, or if it's too high or too low, then you can just basically use the strategy that you use in that game. So first let's check out our array. So 1, 2, 5. So we already know that this array is sorted. If we know that this array is sorted and we want to search for like an 8, we go to the middle of the array, and I realize there are 6 elements here, so let's just assume we go to like a 5. And then we see that 5, the element we just encountered, is smaller than 8. So we know that 8 is somewhere in the second half of our array, I guess. So, and then we just want to go to the middle of that part. So we got lucky, 8 was right there, but we can see that this is like really efficient with larger sorted arrays, where you don't have to go through every element like you do in linear search. You can actually just go through O, log, and elements. So this is much more efficient if you know the array list is sorted. If you don't know, then binary search is pretty useless. But yeah, so today we basically had brief plans into what an array list is and some basic methods that we can use. And array lists you basically want to use if the number of elements you have, you know, is going to change. And if you like say have like a database of users, I wouldn't use like an array list for that, but say you had something like that frequently changes, then it would make sense for you to like use something dynamic whose size you can change instead of like an array. And we also briefly talked about search. There's linear search, which is always guaranteed to work, and binary search, which is more efficient but only works for sorted arrays. So that'll be all for today. Goodbye.